Now we focus on radix 2 inverse fast Fourier transform where n is equal to 2 for n from 0 until 1. It consists of even function where this values is based on n divided by 2 minus 1 for n equal to 2, so the value is 0. And for w negative Rn function, this is based on n divided by 2, so it becomes 1. And we note that the value of g0 is equal to g1. The next one is odd function where k is equal to 2r plus 1, and the value for h0 is equal to h1 where it is equal to x1. So the next one is based on w with the power of negative n function for n points, so n is equal to 2. So we have this function, and also this exponential function is actually equal to cos omega n plus j sine omega n. So when we substitute n equal to 0, we have this function where the value is 1, positive 1 here in the polar form. The magnitude is 1 and the phase is 0. So at this point, for n equal to 1, the value is negative 1. At this point, the magnitude is 1 and the phase is negative 180. So at this point, so based on this value, we substitute in this function of w negative n for n point. So for x0, we have this function, and for x1 we have this one. Note that the difference is the plus minus sign based on this value of w with the power of negative n. So this is the 2-point inverse fast Fourier transform based on xk to determine xn using the synthesis equation. So for this one, at this point, this is g0 based on this value of x0. g0 is equal to g1 for even function, so this is g0, this is g1. And for x1 based on odd function, we have this one h0, and this is since it is multiplied with negative 1, it becomes negative h1. And at this point, okay, this is the summation point, so g0 plus h0 multiply with 1 over 2. So x0, this is xn, is equal to 1 over 2 multiply with this the summation function g0 plus h0. Okay, so this is the equation. For x1, okay, based on this summation function g1 minus h1, please correct this summation into subtraction. Okay, so g1 minus h1 at this summation point multiply with 1 over 2. So x1 is equal to 1 over 2, this is 1 over n, multiply with g1 minus h1. This is a butterfly signal flow for 2-point inverse fast Fourier transform.